Hi everyone, my name is Nikola and this is my video for calculus. So my problem is 209 and it states the following. So a lampshade is constructed by rotating y is equal to 1 over x around the x-axis from y is equal to 1 to y is equal to 2. So what we need to do is determine how much material we need to construct this lampshade. That means that we need to find the surface area, and it says here that we need to find it accurate to 4 decimal places. So first we're gonna solve for the x values of the function. We know that y, or the main function, is equal to 1 over x. We also know that y is equal to 1 and another y is equal to 2. So we proceed to find the x values so that we can graph a visual representation of all of this later. So if y1 is equal to 1 and y2 is equal to 2, then x1 will be equal to 1 since 1 over x is equal to 1, and x2 will be equal to 1 half since 1 over 1 half is equal to 2. Now we can graph a visual representation of the lampshade. So we begin by graphing the function y is equal to 1 over x with the values of x and y that we found in the previous step. So the main function, y is equal to 1 over x, is this one right here, this and this. But notice that we are graphing the surface area of a lamp. We're trying to find the surface area of a lampshade. And since we are graphing a lampshade, and we are aware that this function is rotating around the x-axis from y is equal to 1 to y is equal to 2, we draw this additional line and plot the points as well. So these are the values that we found, 1 half comma 2 and 1 comma 1. So now that we graphed the function, we have to obtain the derivative of the function g of x, which is the main function, and its square value, since this is a vital part of the surface area formula. So we know that 1 over x is equivalent to x to the power of negative 1. 1 over x is the main function. We convert the main function into this form because it's easier to solve for the derivative. So the derivative of x to the power of negative 1 is negative x to the power of negative 2, and the square value of this derivative is x to the power of negative 4. So now I will explain. Now you'll understand why that's an important step for the formula. So we proceed to obtain the surface area when revolving around the x-axis. The formula for the surface area of a surface revolution is the following. The integral from a to b of 2 pi times f of x in this case is g of x, the main function, times the square root of 1 plus the derivative of the main function squared. That's the value that we found, x to the power of negative 4 in the previous step. So we set up the formula as follows. We can move the 2 pi from here outside in front of the integral since it's a constant. And notice that we are working with a decreasing function, and therefore we will integrate from x is equal to 1 half to x is equal to 1. Notice that the main function, g of x, or r, represents the radius. Something that I plotted right here so you guys can see it clearly as well. So this is going to be the radius, the y value, and the value of the square root of 1 plus the derivative of the main function squared represents the length, which is right here, as you can see. And this gives us a familiar function, 2 pi times the radius times the length. So after we found all of these values, we can plug in the following values into a calculator. So 2 pi, which we took out in front as a constant, is multiplied by the integral from 1 half to 1 of x to the power of negative 1, which is the main function, aka the radius, times the length, which is the square root of 1 plus x to the power of negative 4th, which is the value we found, the derivative of the main function squared. Once we plug all of this into a calculator, we find the value of 1.6714. And when we finally multiply this by 2 pi, which is the constant we took out previously, we get the final value of 10.5017. That's the surface area of the revolution, which in this case is how much material we need to construct this lampshade. Thank you everyone, and I hope you enjoyed the video.